All right, so now it's organic reactions here. All right, so we are going to do those reactions. We don't have to worry about this. Now, here are the main reaction. Like I told you, it's substitution, elimination, addition, and esterification. I don't think you're doing fermentation, saponification, polymerization. You don't do all of that. Am I right?
No, we don't.
You don't remember? Yeah, because I know they used to do them. So you're doing the first top two, this substitution, addition, elimination, and esterification. So it's basically for reactions. When we're doing something like halogenation, dehydrogenation, it falls under these four. It's a type of a substitution or addition or elimination. You got it?
Yeah.
Yeah, it just depends who will eliminating.
Yeah.
Yeah.
So it says we do combustion, we do substitution, we do addition, we do elimination, and we do condensation.
Yeah, it's all of those ones.
Yeah.
You see, when you say what is that one? Combustion. It's where there is oxygen.
Yeah. Oh, where's the wait so what's the product? Carbon dioxide, sir? Oh.
Normally you find a carbon dioxide and one of the what you call what is this one? Yeah, you get carbon dioxide and sometimes carbon dioxide and water.
Oh, okay.
Yeah. Let me show you chapter here. Yeah, carbon dioxide and water. So you'll see. So it's basically it's what you know. It's those ones, no matter what name they call it. You see when you're doing acid and bases and redox reactions, they fall on those one, all those four. It's a type of those ones. But it feels like you're doing a whole new equations. Meanwhile, you are not. Let me see. Yeah, I don't think. Yeah, I had those reactions here. Oh, no. Okay, because I know I do have them here, unless I don't see them here. But it gotta be here. Okay, if it's not here, I'm just gonna give you my own example. Yeah, there we go. Can you see? That's oxygen. Can you see?
Yeah.
Yeah. That's why you've got delta H. There is some heat there. You get carbon dioxide and that one. So let's give an example. Let's say, for example, let's take a methane, which is C4, and then double the 4. I mean, it's a butane and then 10. And then you're like, okay, guys, plus oxygen. Let's say plus O2. And then what are the products? Simple. We know it must be CO2, carbon dioxide, and then plus H2O all the time. All the time, you must get this. Remember, like yesterday, when I said when there is heat, I always think of something evaporating. It has to be a form of water or a gas. And you see, there we go. Yeah. Then you balance the equation. When you balance the equation, there is something that I call HO, H-O. Oh, wait a minute. Meaning hydrogen and oxygen, you balance them very last. Oxygen will be the last one. But I know in other times, when you're doing the other one, it's actually the last one. So here's I go. I've got 4 carbons here. Here I've got just 2. I mean 1. So for me to get 4, I need to put 4 carbons here. But as I'm balancing the carbon, I'm altering the oxygen. Oh, don't worry about oxygen. Just wait and don't disregard it. I said, okay, fine. Go check the other element. No other element left. Okay, now we come to O. We go with H first. There are 10 hydrogens. there is 2 here. So I just need to put 5 here in front. That's how simple balancing is. Then I say, but as I balance hydrogen, I'm altering the oxygen. Can I go for oxygen? Yeah, now it's time for oxygen. You normally put half, whatever it might be here. So here how it goes. The right-hand side, I've got 4 times 2, which is 8. 8 plus 5, what is 8 plus 5? It's 13, it's 13, isn't it?
Yeah.
Yeah. So you'll find here oxygen will be alone. So that means I just need to put 13 divided by the 2. That's all. Or you just simply say, wait a minute, I need to put some number there. I need to put some number because I know I'm going to double every one of them. What number should be there so that I get 13? Meaning x times 2. That means 2 times x so that I get an answer of 13. When you solve your x, it's actually 13 over the 2. So that means where there is x, you might keep it as, because we are allowed to keep fraction, even you, 13 over the 2. Then you say, I'm done. But because you don't like fractions, you guys, you want to multiply by the denominator of 2, the whole equation. So meaning you times here by 2. And then by the time you come here, you multiply by 2. That 2 is gone. And then when you multiply this one by 2, it now becomes 8 here. And then here it becomes 10. You're done. You should have left it as fraction. That's it. It's balanced. Look, 2 times 4, 8 carbons. Look, 8 carbons. 2 times 10, 20 hydrogen. 10 times 20 is 20. 13 times 2. It's a 26. You've got 10 oxygens here, and 16. So, 26. Yes, sir.
So you treat it like an equation.
Yeah. Yes, because this is an equation. You see that arrow? This arrow is an equal sign. It's what I was trying to tell you yesterday when you had something like this. Let's say you had A plus 2 electrons. And then let's say you get a B. And then the next equation, you had C gives you 2 electrons. And then let's say plus a D. When we said they cancel, it is exactly that, because here's what's going on. That electron here, really, if you transpose it like an equation, when it comes over to the other side, it must change the sign. It must become negative 2 electrons. So here it's gone. So that when you consider that it is an equation, it is a mathematical one. So C plus A, 2 minus 2, they cancel. Yeah, exactly like it. 100% the equation. You can divide, you can take square root. That's what yesterday when you asked me, I said, can I treat it like an equation? I said yes. I said yes. So it's the same thing. Let's say you had here, you had 5 H2O, let's say plus oxygen, O2. And then the other side, I'm putting as an equal sign. Other side, you had 3 H2O, let's say plus, let's say plus N2. So you've got common factor. That one and that one is common factor. So you transpose this here where it's going to be minus. So it's basically 5 water minus 3. You're left with 2. So you got 2 H2O and then plus O2 equals to, of that arrow is N2. That's the equation. It's exactly 100% the equation. Yes, sir. It is. Yeah. So most people, they never realize that, and they don't even say it here in chemistry. And here's the thing. Every time when you have an equation, whatever is on the left, it will always be equals to the right. Let's say, yeah, it's a law of conservation of mass. If I were to calculate the number of moles in the red box, they are going to be equals to the number of moles in that one. Even the mass, if you started with 5 kg and 3 kg, which is 8 in total, whatever you produce that side all together is still 8. You don't lose. It cannot be created or destroyed.
Yeah.
Yeah. Most people, they don't see that. They kind of like, oh, we're calculating the number of moles. If I knew the overall here was 100, I get this one to be 20. I know the remaining 180. It's for that one. It must balance all the time. You don't lose a thing. Yeah. All right. Yeah. So that's how it works. The whatever you're calling it, combination. Okay. We're good, right?
Yes, sir.
Yeah. But look at it now. Let's just kind of look at that one combination. Here's what happened. The carbon. All right. In other words, if you were to split this, the first part, like how I show you how we do the equation, you've got carbon with a hydrogen. This side, it's oxygen, but you need to write it twice. You've got an oxygen with another oxygen. So which means one takes a plus, one takes a minus. Same thing with oxygen. One pretends to be a plus, one pretends to be a minus. Like I said, the negative on the left will fall in love with the positive on the other side. And then the positive on the other side with that. Can you see? You've got C and O, which is that one for carbon dioxide. You've got H and O, which will form that water. It's exactly the same thing. So what is this? We are swapping. That is substitution. Actually substitution, but we are using oxygen. So now they give it a special name. They call it combustion. Yeah, it's only those four in all of them. Same thing with acid and bases and redox. Is those four reactions all the time. They just, the reason why they give them other names is because maybe you are using a special letter. You just want to be more specific. What is it that you are really substituting in there? You know? Yeah. Like actually when you basically, when you are sweating, you're on it, maybe say you are running and you are sweating, you are actually extracting that water. But we can call it sweating. When you hear the word sweating, it doesn't really specifically say, let's extract water. If you say we're extracting water, you're like, oh, okay, good. Dehydration, we're extracting water. It's like, oh, okay. We just use a whole lot of terms for the same thing, and until it looks like we're doing some new things we have never known. Yeah. Okay, so there we go. All right. So let's come to these reactions here, because these are the main one. It's what I even saw the same thing there. So normally with reaction, this is what happened most of the time. You must start off with 1 plus B. When you add them, they combine to form one unit, meaning you start with 2 things, they become 1. And then the reverse of that, when they split, meaning you start with 1 thing. They'll call it to decompose or dissociate or splitting, whatever it might be, or subtraction or elimination. Then they split back into A plus the B. We're good, right? It was the same equation. I just did the back and forth, the reverse of it. Do you see that?
Yeah.
Yeah. Okay. Then another one, it could be, you might start with 2 things. Let's say you got A, B, and then you got plus the C. This is a substitution which is not fair. So in other words, B is married, it's partnered, it's married with A. If C is a big boss, C will say, Mr. C, I'm going to knock your head, get out of there, let me go in. Then C goes in, Then we chuck B out. Can you see? It's
Yeah.
a substitution, but not a fair one. It's not fair. It's like this one has his own girlfriend. You go take him the girlfriend. You never swap. He's without the girlfriend now. That's unfair. That's a
Yeah.
swapping that is not fair. Then another swapping that is fair, a double one, which is called metathesis. You got A with B, and then plus you've got C, say with D. Now C comes and said, Mr. B, get out of there. All right. And then Mr. B says, no, it's fine. I'm gonna get out of there, Mr. C. But you know what I'm gonna do? As you come in, I'm going the other side. Me, I'm gonna partner with D. Now that's fair. Everybody, it's an exchange, a fair exchange. This is what we call double substitution or metathesis. That one is a single. It's called it displacement, but it's a swapping. You get what I mean? Like
Yeah.
in soccer, it's fair because one goes out, one goes in. You get what I'm saying?
Yeah.
There is a time when there is maybe they do red card. I don't know. I don't know much of the soccer. I think when they give somebody a red card, he gets out. No one come and replace him. If they were 11, they are now 10. I don't know if that happened. It's like you check somebody else, but you don't replace him. So that's exactly what's happening with this reaction. Then the last one, it's basically this. You kind of have it like, let's say it's A, B, C in that order. Nothing happened. It's just a rearrangement. Instead of writing it as A, B, C, now it becomes B, maybe say C, A. In other words, nothing was lost. We just rearranged. It's like you when you arrange your maybe your study books. Maybe today you put maths, physics, chemistry, whatever. Next time you put them upside down. You juggle them up. That's all. It's all there is with all reaction, everything in chemistry. So then when we're doing all of that, if we're dealing with a hydrogen, we say, let's call this one acid and basis. Then if we're dealing with electron, let's call it electrochemistry. When we're dealing with oxygen, we say, let's call it combustion. You get it?
Yeah.
Yeah. Once you understand that, you just know you play around with the same thing. All right. So fine now. All right. Now we have explained a lot. So we're going to start with the substitution. Yeah. Here's substitution here. All right. So let's give you this one because you need this one because last time we spoke about ultraviolet light. It says any reaction in which one atom is replaced by another. You see, we are just replacing one atom by the another. So in other words, one will go in there. It's a swapping. It's this swapping, the fair one. Yeah. You see, it's an exchange. Let's swap. Let's swap. That's what it is. You'll see. It says use to place a halogen, Antoine. You don't even need to know that. What you need to know, an exception is hydrobromic acid, HBr. Hydrobromic acid does not work. You've never seen them using this one for this one. They say this reaction needs ultraviolet light or energy. So what's happening here? Let's write that one in a normal. You got C bonded with Z. Up, down, right. Up, down, left. You got hydrogen. 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 And then plus chlorine. Now, every time when you write group 7, chlorine, fluorine, bromine, they must have a subscript too. They are diatomic. So that means the halogens, you take oxygen, you take nitrogen, you take hydrogen, all of them, they must be written with a subscript 2. And the halogens, all the time, they are gases. Other ones, you can have them alone, like you just write sodium like that plus that. But once you put them in an equation, these gases, everyone must have a subscript. They go as a partner. If it's Cl alone, it has to be with somebody else. Maybe say HCl, like an HCl. Now they are two, it's happy. They get lonely when they are alone. They rather go with their twin brother or find somebody else. All right. All right, so there we go. So what's happening there? You've got two chlorine. That means you got Cl and another Cl. So one pretend as plus, one pretend as minus. So then when we come here, let's say we kick out that H. We say H, get out of here. That means one of the Cl will go in there. Then the H says, thank you. I'm going to partner with that one there. Do you get what I'm saying?
Yeah.
It's a swapping. Then you've got that HCl and that one goes there. Then it's called substitution. I always think of soccer when they say substitution. When it's substitution, they swap. That's what I know. I know they swap. We're good. I think we're okay. You're getting that one. All right.
Yeah.
So this is exactly the same example here. You've got CH3 plus CH3, there's bromine. So if we are going to swap, that means if I'm going to extract one of the H here, I'm going to be one short. The H will be two here. Then that H would have been replaced by one of the Br. So the Br should come here. The H that went out will partner with that one there. That's the results that you are getting. Can you see that? Because it becomes one less.
Yeah.
It's substitution. So one went there and the other went the other side. But neither one of them is lonely. Everyone has a partner. So substitution, yeah. So that's how when you say substitution, I say which one? The double one, metathesis or displacement one. All right. Now, you see, now you understand substitution, right?
Yeah.
Swapping. Now we're coming to elimination. Actually, I would have loved to go to the thing. Addition, because it's the opposite of that one, but it doesn't matter. Let's deal with elimination. Any reaction in which atoms are eliminated from another molecule can be done by this. So if you want to understand what is this one here, it's group 7. In other words, it's H with the, let me say, GR7, group 7, meaning hydrogen with chlorine, hydrogen with fluorine, hydrogen with bromide. You get what I'm saying? Like how we said it here in the beginning here, all these guys. Can you see that?
Yeah.
Yeah. Then we go for hydrogen. You see, it's a gas. Then we go for water. Those are the main ones. If you memorize group 7, hydrogen, of which you can see it here. Yeah. H2O. In other words, if I remove the O, you've got that one. You say hydrogen with something. In other words, what's happening here? Here's what's happening. You are always having hydrogen should partner with something. That means hydrogen could partner with another hydrogen, or hydrogen will partner with the oxygen, or hydrogen will partner with group 7. Can you see? All of them start with H. Look at the first one. The one that says HH. It's actually starting with H. You just ending up with the H. And then the next one is starting with H. You might end up with the chlorine. You might end up with the fluorine. You might end up with the iodine. You might end up with the bromine. You get the sense, right?
Yeah.
Yeah. And then the next one, I'm starting with H. I'm just ending up with the O. Then there's just a double thing. So I know it's H and something. Elimination.
Yeah. Yeah.
Yeah. So maybe you should call it I don't know, maybe HI, but with the sound of H, elimination. With an H. Elimination. Then you know
Yeah,
you're dealing with something that starts off with an H. Elimination.
like acids.
However you're gonna remember it, but I hope it's gonna help you, right?
Like acids, sir.
Yeah. Oh, yeah. Yeah. You can think it more like an acid. Yes. Because an acid, you're eliminating that H. Yeah. You say, well, in acid, I'm getting rid of an H. Yeah. Elimination, I'm getting rid of, there's an H thing in there. H and something. Yeah. That's right. Absolutely. Absolutely. So now, because we say elimination, what do you call this guy? That one is going to be hydrogen. Isn't it right?
Yeah.
So if I'm eliminating hydrogen, I said you put the word D. It's going to be dehydrogenation. Can you see that?
Yeah.
But what is this next one? It's actually hydrogen, not alone. The X belongs to the halogen. So I need to put a D and hand it with the, it must end with the nation. So they're gonna kind of make it short. They'll say dehydrohalogenation. Can you see that?
Yeah.
Yeah. And then the next one, because this is water, but the name of water is hydration. Hydrate is water. Hydration or hydrates. So that means it must be called dehydration. Can you see?
Yeah.
But they're all elimination. Can you see? That's why I said elimination is just a type of elimination. You just depend what are you eliminating there. All right, so let's go on now. Let's just see. All right, so here we go. So in this one, you got single bond. So when you eliminate hydrogen, meaning H2, that means I'm going to pick H from one of the carbon. Then you go to the other carbon. You cannot eliminate two from the same. Let's say from this one here. So those two are gone. When they are gone, they are bond. Those two bonds, they make one bond there. Then you've got a double bond. So all of that is gone. You've got a double bond, which is now that. Exactly what I wrote there. I just wrote it as a structural formula and then plus H2. Now, can you see the name? It's called what? Dehydrogenation, or simple, elimination of hydrogen.
Yeah.
They say this type of RXN reaction takes place in industry in what is known as a catalytic cracking unit. Remember when we talk about cracking, complex molecules which are long, like long chain, more than 10 for you. We did that yesterday.
Yeah.
Yeah. Then what's going to happen now? You must know it. This reaction, it has the reverse of it. Where you're reversing it, meaning you're putting back hydrogen. That means the DE will go. Now you'll call it hydrogenation, putting back of hydrogen. Like here, every DE, the prefix will go. Then that's the other reaction. All right, let's look into the next one. This one here, alkyl halides can undergo elimination. This is known as D. There we go. D what? Hydro for hydrogen.
Yeah.
Halogenation for halogens. It's a combination. Wait a minute. You did Markovnikov's rule, didn't you? The rich becomes richer, the poor becomes poor. Didn't they say something like that?
No, they didn't mention that. So.
Okay, in place of X, that's where you've got like a chlorine, brom. That's a group 7. So that means take away one of the group 7 and the hydrogen. That's what it's telling you. The name tells you what to take out, hydrogen and halogen. Then again, they form a bond there. So those two together, they're going to marry each other. They're going to be XN. That's it. I hope it's making sense.
Yes, sir.
Yeah. All right, so let's go on now. Now we are going to remove water. There we go. You see, dehydration. Now this one, it's important because it says alcohol can undergoes, because for water by itself, that means you are eliminating the H and also the OH. So there should be the OH in the equation or the formula. H is already there, but you want the OH. OH is for the alcohol. So there you can see it there. So that means I need to get rid of this alcohol and that H. Those two will go. They form H2O for me. And here I've got a double bond. And you see, it's straightforward, isn't it?
Yeah, I see.
Yeah. All right. Now, you see, now we're done. Elimination, addition. I would have loved it when they called this one subtraction, this one addition. Because remember, you've got the other one, what was a substitution. All right. So now we're doing addition. It's basically the same thing. The same thing you saw earlier on, which was that. Here, this one is just our group 7 on its own, meaning, like I said, chlorine loves to go with its twin or somebody else, the H. And then iodine, 2. Let's say Br2, all of that. So now we're putting it back. So that one, it's just the halogen on its own. I think, you see, with the elimination, I believe you can have, like, let's say C, C, C. And then here you've got, let's say you've got a bromine, and also there you've got a bromine. And then you get rid of the bromines, so which means it's just halogenation by itself. There's no hydrogen. It will be dehalogenation, but they just did not show it because it was exactly all of this which we were extracting, and then you put them back as well. All right, so they're telling you double bond, triple bond. Well, it's just a reverse of this. You had a double bond, you must break that double. So the double bond, you must break it. It comes here, it gives birth to 2. So there is 2 things here. You've got an H, you've got an OH. One of them will attach itself in one of the bonds. That's all. It's exactly the same thing. Okay, it says it takes place in the unsaturated, meaning double bond, triple bond compound, which are usually more reactive than saturated. So can you see double, triple, multiple bonds are more reactive than single bonds? Okay, it says it takes place in double, triple bonds. Okay, we know what to do here. Let's go back here. Let's go here. So here we are. This part here, you are basically given carbon bonded with carbon. You got hydrogens, H, and another H there. And then you got up, down. You got H, another H there. And then when you look at the wide bond, you say, well, I can break the wide bond there so that it produces 2 extra bonds. One, I'll put it that side, one, I'll put it that side. Then I said, okay, I've got 2 chlorines. Each one will find its place, like that. That's it. So what did we do? We didn't, this was halogen. So this must be halogenation. Okay, addition of a halogen. Or if I want to be a little bit more specific, because it's chlorine, we can call it chlorogenation. But it's a halogen. Are we still together on this one?
Yeah.
Yeah.
Yes, sir.
So can you see, you move from the double bonds, which were alkene. You came back to single bonds, which is alkane. This thing is just it's just there. It's just nature. There's no need sorting the theory. It's in front of your eyes. You're like, wait a minute. That's a double bond. That's an alkene in. Now it's a bond. It's an alkane. So when they ask you, what do you get? You just write it down and you can see it with your eyes. You see?
Yeah.
All right. So here's the next one. Now we are going to put hydrogens. Hydrogen, a catalyst, is normally platinum, palladium, and nickel. Known as hydrogenation because we're putting the hydrogen. So this one, they should say known as halogenation. You're putting halogens. So again, you're breaking the double bonds or triple bonds. If it was triple, it becomes double. If it was double, it becomes single. Come on, from 3, you go down 2. From 2, then 1. Same thing. So then we break that one. You've got that. So H and H. Yeah. What did we put back? Hydrogen. What are we going to call it? Hydrogenation. Putting back of hydrogen. Addition of hydrogen. Okay, now we need to put water. We need to put water back. We know water is H plus OH minus. You won't see it going back as like this, as H2O like that. You see it broken down. So there it is. Can you see it's water there? So that means when we break one of the bond, let's make it one there. Then you've got that. You've got that. The H might find itself here, and then the OH is there. And you're like, now wait a minute. Where there is an OH, it's an alcohol. They don't need to tell me it's going to form an alcohol. You see, alkene becomes an alcohol. It's just in my face. So it's hydration instead of dehydration. All right, so which is this one here. Now here there is that hydrogen and halide, meaning halogenation. Hydrogen and halides. You see? Halogens. Halides are the halogens, group number 7. So I could have called it hydrohalogenation. That's what it is. Now, when you have this one, you have to be careful where you put an H now. This is what they call, there is a rule called Mechanikov's rule. Let me give you my own example. Let's say we've got C bonded with C, and then double bond, we got C, and then 1, 2, 1, and then 1, 2. Right, and then I've got, let's say I've got H with something else like chlorine. Let's use that one there. How will it work? The moment you break that green bond, now you have extra bond here, a bond here, and a bond there. So what you need to attach in the yellow, you must attach H and also Cl. So the H cannot be put anywhere. You look at these 2 carbons, the 2 carbons where there was a double bond. Look at carbon number 1, like how we're doing primary, tertiary alcohol. This carbon here, it's only bonded to 1 carbon. It's poor. It's a poor one, this one.
Yeah.
No. I'm saying it wrong. This carbon here, check how many hydrogen, I mean to say, it was bonded to. Actually, this one had 1, and then this one had 1, 2. Yeah, I almost said the wrong thing. The first carbon has 2 H's. The second one, 1 H. The one that is rich with H, the black H's, that's where the H should go. So that H should belong here. That you must be careful of that one. And then Cl comes here. When you're dealing with hydrogen and something else which is not hydrogen, put the hydrogen where there's plenty, lots of hydrogens. This is called Mechanikov's rule. They won't ask you what rule it is. They're just gonna make you do this, but you must just be aware where to put the H in its place. Now, let's look at this example here, what they've got. Let's look at this one here. Remember, the X is actually one of the thing of the what you call. Okay, let's do this. Let's make one bond there. So that means you're going to have one bond here. You're going to have, I'm going to put one at the bottom. So when you look at the first carbon far left, it has 2 hydrogens. The carbon far right, it also has 2. It's a tie. It's a tie. So it does not matter where you put the H. So you can put the H here and put the X here. Or you could have done it vice versa, put X here and put the H here, because it was tie. None of them was rich with hydrogens. Now they give you another example, which is, we're picking it up from here. Let's pick it up from the white box. The white box, because it moves from white and comes here. So the double bond, it's actually here. It's actually here, the double bond. So when you break that double bond, let's make it 1. It gives birth to 2 bonds, 1 here, 1 here. So let's look at the carbon that is on the left, the one that I'm pointing at. How many hydrogens on that? 2. 2 here. How about the next carbon? It only had 1 hydrogen, so it's a poor one. The first carbon here, the one with 2, it must take the H. So H comes here and X goes here. You can actually see the results there. Can you see? It's called Mechanikov's rule. Yeah. So this part is done. So what's next is esterification. Esterification. So I already put some example here. Esterification. So the block, the stuff in yellow, this is alcohol. This is alcohol. This is your alcohol. And then the other stuff, let's just put it in the purple, that one there. It is your acid, carboxylic acid. This is your acid here. Carboxylic acid. Well, we have seen the functional group. We saw it, it was that. You remember that, right? Alcohol, we saw it was that one there. All right. So what's going to happen when you take alcohol, you combine it with acid, but I need to say this. We do that using a concentrated sulfuric acid. Don't forget that. I said it yesterday. Concentrated. I'll just write con. So you'll get water and the ester. Why? Because we are going to take the OH there and the OH there. We want to bond them together. If you could write the equation in reverse, bring that OH closer to that OH. It's like when you hook up the cars, okay, or a trailer. These two need to join hands, OH and that OH. But there is something you need to know. I'm going to write it in reverse. Let's write this one as it is. So it's CH3. I already did, but I want you to see that. CH2 and then CH2 and then bonded to the OH. Okay, let's make the OH in white. OH there. Then I'm going to write this one backwards. I'm going to start with that purple OH, but I'm going to make it green. So I'll write it OH. So I'm starting with this one, then bonded with carbon, which has double oxygen, and then bonded with CH3. Good. So now we are about to marry these two. Yeah. You see it? Is it making sense?
Yeah.
Yeah. Now, do you remember an acid? What is the function of an acid, a normal acid? What must it donate?
A hydrogen.
Good. So the purple one or the green one, it is the H. You see that?
Yeah.
Yeah. So that means that green H there needs to go and partner with that OH, because people, once you write water, they don't know where the OH come from. What do I mean? Both of them got OH. This is OH here. This is OH here. They just think OH is just N. You need to know where it comes from. It comes from the alcohol. From the left here, the yellow one, the white OH. You get it?
Yeah.
Yeah. So that means I can write it in this manner. I can say now you have H bonded with the OH so that you can see color code. The green comes from here. So the oxygen that remains. So here's how they're going to go. Watch now. I'm going to remove them. I'm putting that one down. And then I'm removing the H there. Can you see? Can you see what's left?
Yeah.
Can you see what's left? You just put it together as they are. Bring them close to each other. So I bring them close to each other. So now you now have that. You just remove S the way they are, and then you now have this, which is exactly what we have down here. So that is your ester. It's esterification. Okay. Remember, normally the last thing we put down is an acid. We start with an alcohol normally. So here there's a glitch here. We need to fix it. Let's look at the alcohol. 1, 2, 3. We had 3. 3 is MEP, it's prop. This one was propanol. It must be written first, that one. And then this one had 1, 2, 3. It had methyl. Okay, methanoic, methanoic. It was methanoic acid. This one must be the last one. So that means you're going to put that one, because there was a mistake here. The name of this one should be propyl, alcohol first, then methanoate. Methanoate. That will be the name. Yeah. So this is esterification. We good, right?
Yeah.
Yeah. It's basically this type of reaction, no matter